So we're going to learn about our last conic today, hyperbolas. We've done circles, parabolas, and ellipses, and now we're ready for hyperbolas. So basically we're just going to talk about graphing them, and then at the end we're going to talk about how you can tell by looking at just the equation what it is, and then how to actually graph each one, which is like a good review lesson at the end. So go ahead and copy down this slide, please. So this is what a hyperbola looks like. It goes this way and that way in this case, and this one's on the top and the bottom. It can go either horizontally or vertically. It almost looks like parabolas, right? But just two of them back to back. They're not parabolas, but they kind of look like it. These dotted lines are not actually part of the hyperbola themselves, but those are the asymptotes. We talked about asymptotes briefly when we did sequences and series. An asymptote is a line which a graph will get closer and closer to but never actually reach. So our hyperbola extends on to infinity, and it always gets closer and closer to that dotted line. It hugs it closer and closer every step it goes, but it never actually quite gets there. So that's called an asymptote. The dot in the middle, of course, is the center. Okay? All right. Go ahead and write down this slide, please. So, as you guys can see, there are two different kinds of hyperbolas. There's the horizontal one, like the one on the left here, and then there's hyperbolas that extend vertically, like the one on the right. So, how can you tell them apart? Well, here's the key thing. You guys might want to add this to your notes. When x minus h is squared is positive, then you have this situation where it's on the left and right. Notice how there's no negative in the front of this x minus h. It's a positive, right? Now the y minus k has a negative in front of it. That's your indicator that it's going left and right. Likewise, when the y minus h is squared, I'm sorry, that should be y minus k actually, you guys. Sorry. When y minus k squared is positive, that's when you have a vertical type of hyperbola. So the h and the k, guys, those are your center just like they always have been. Now the a and the b, they act a lot like the x and y radius on an ellipse. It's just that instead of giving us an ellipse, it makes a box. So we'll see that come to life a little bit more when we do an actual example. So go ahead and write down number 1, please. So the first thing we're going to do is find the center, which, since there's no h and k, is 0, 0. Right? And I'm still going to call it the x radius and y radius. Once again, those are not real math words, but for the purpose of graphing, it makes it easier to do. So what's our x radius? And what's the y radius? Okay. So let's go ahead and graph it like we would graph an ellipse. Up to a point, that is. Okay, so my center is 0, 0. My x radius is 5, so I'm going to go left and right 5. My y radius is 1, so I'm going to go up and down 1. And this is where we're going to stop. Okay, so this is where it gets different. We're not going to connect those 4 outer dots with an oval this time. We're going to make a square, or not a square, a rectangle, be more appropriate. Yeah. Now that's not actually our graph. That's a tool that we're going to use to get our graph. What this tool does is it helps us get the asymptotes that I was telling you guys about earlier. Now here's how it helps us get the asymptotes. It's going to, if you draw the diagonals through that box, it creates your asymptotes for you. Now you want to try to be as perfect as you can with it, although it's not a perfect world, so it might not come out to be exactly what we want, but we'll do our best. It should ideally go through the center and through both corners, but as you can see, mine's not working out exactly right either. But that's okay. We're just estimating a graph here anyway. But you're going to do both directions, so all right, close enough. Now, before we go any further, that's not our hyperbola either. Those are the asymptotes, and those help us to sketch where the hyperbola will be about approximately. Now, the hyperbola could be on the top like this. Let me show you. It could be like this, or it could be on the sides like this. It's not both of them though. So it's either the purple part or it's the orange part. Let me ask you guys, which one is it? Well, let's see what. Now I told you guys whenever the x squared is positive, and that's what we have here, right? The x is being positive, right? Which direction was it? Let's go back to our slide here and take a look. When x minus h is positive, where was my hyperbola? On the top and bottom or left and right? It was on the left and right. So, which one is it? It's the orange one. So, it's only going to be the ones that are on this side. And how you do is you want your vertex to be right on the side in the middle of that rectangle. And you draw the hyperbola getting closer and closer to the asymptote, but never quite actually touching it. And you do the same thing on both sides. And that's it. So it's the one on the sides because the x is positive. Let's see what happens on the second one. I'm going to write down number 2. Okay, so now what do you guys think we're going to do on this one? Yeah, we got to get it equal to 1, right? So we're going to divide everything by 49. Just like with the ellipses. So the whole first part is just like you'd usually do with ellipses. 7 goes into 49 7 times. So after we clean this up, we have the following. Okay, so what is the center? 0, 3. And the x radius? It's the square root of 7, which is not a perfect square root, so we're going to estimate it. And I believe last class somebody told me it was 2.5. If somebody wants to double check that to let me know for sure. We're going to estimate it to be about 2.5. No. And then the y radius would be 7. The square root of 49 is 7. So there's that. Let's go ahead and graph it. Okay. So my center is 0, 3. That's over none up 3. My x radius is 2.5, so I'm going to go left and right 2.5. And up and down 7. Now what? What do I do at this point, guys? we make a box around the 4 points, right? Not an oval, but a box. And now what do? We draw our asymptotes, right? And now we're ready for the final touch where we actually add our asymptotes. Now let me ask you guys, think about it for a second, don't shout it out right away. Where's it going? Are the hyperbolas going on the left and right of the box or on the top and bottom of it? Do you guys agree it's left and right? Why is that? Because the x squared is positive. And this one's going to be really wide because it's so long. But there it is. Notice how I'm wording it to you guys. I'm saying the x comes first, the x squared is positive. A lot of times people will think it's just whatever letter comes first. So x squared comes first, therefore it's on the left and right. It's not which one comes first because I can rewrite this in another way. I can put the negative y minus 3 squared in the front and then put plus x squared over 7. That's the same equation, and the y comes first. So it's not about which letter comes first, it's about which one's positive. Okay, so keep in mind it's not about which one comes first. That's a common mistake I've seen people make. All right, we'll do one more. Go ahead and write down number 3, please. Okay, so number 3, just like on the last one, we're going to start by dividing. And what we're left with then is 1 is equal to 4 divided on the top and bottom leaves us with 1 there. So my center would be what? Now let me ask this, what's my h? My h is negative 1. It's the one next to the x, right? There's a positive one, but you know when you take it out, you got to change the sign. And what's my k? Positive 1. I know that this one comes first, but remember, it's the x followed by the y, even if they're in the wrong order in the equation. All right, and then we have the x radius. Careful with that. What's the x radius? It's the one under the x. So it's 2. And what's the y radius? That would be the 1. 1. Now we're ready to graph. Oh. Okay, so my center is left 1, up 1. X radius is 2, so left and right 2 spaces. And y radius is 1. Go ahead and draw our box. And if you have any questions, just stop me. I'm just kind of buzzing through this. Nothing new here yet. Okay. So where's my hyperbola at? Is it going to be on the left and right or the top and bottom? This one will be different, right? It's going to be on the top and the bottom because this time the y minus k is the positive part. So that means my hyperbola is going to start from the top and bottom of the box. There you go.